Can everybody hear me okay?
Yeah.
Okay. The moment of truth. Okay. So this is from zero to capacity planning, and I have 41 slides for 30 minutes, so this is going to be a little quick. I did my best to try to chop content, but let's get started. So, my name is Ines Sombra. I work for a company called Fastly. I also help run the San Francisco chapter of Papers We Love, and I'm a random mood on the Twitters. If you need me by email, it's ines@fastly.com. What is Fastly, you may ask yourself. Fastly is a content delivery network, and we have points of presence around the globe. And basically, you bring your content to us, we spread it, and we help make your application faster by putting the content close to where your users are. So also, as you see from the map, we have to be like, the entire infrastructure and entire systems have to be both globally distributed and highly available. But I'm not going to talk about that today. I'm actually going to talk about capacity planning, or what I think about it. Like, this is the way that I think about this talk right now, is I think about it as a journey of discovery and ingenuity. And the reason that I think about it that way is because I'm not necessarily a monitoring person. Like, I'm just going to say it. I have, in my entire career, not met a person that actually would take a bullet for the monitoring solution. So if you're one of those, I would really like to meet you to know what you're using. But this is big, but I started thinking about what would be interesting to talk about in this crowd. And this is what I came up with. So also, this is the point where I make a disclaimer that my views and everything that is reflected in this talk is should be a reflection of me, not my coworkers, because those are lovely people and they really know what they're doing. But I thought it would be interesting to be like, okay, I don't know what I'm doing with this specific thing, and then it's either going to be a shit show or it's going to be okay. So it's going to be an experiment, so bear with me. So this is how, in my head, I think about capacity planning. So we instrument our systems to kind of get an idea of how they work and then what happens with them. Then we put some monitoring and alerting on top of this instrumentation to actually be able to act when things are not necessarily the way that we expect them. And then this realm on top with the yellow has been this for me for a long, long time. I've always seen it as something esoteric or something that where I could be lazy and punt it on somebody else, and they're like, this guy's problem. So, but I really wanted to push myself to be able to understand it, and this is the top of the story that I traveled, and this is what I did. So we start with day one with zero, absolutely zero context about this, and then I ended up talking to several areas of my organization, and then I went to see what the literature had to say, what the industry did, and I call that rituals and myths. And then I tried to put everything together and actually put it into practice. So we have that as a section, but this is kind of how it looked like in my head. So we start at zero, and this is the way I start. It's by zero, not only just I mean zero, but I mean zero and water up to my neck. And it's okay, it was a very ocean moment. And I tend to like to put my talks in context of a work situation or a work problem, or let's call them situations. And this was my very convenient situation. This graph is a New Relic graph. It doesn't have a lot of details, so you can get at least the gist that I want you to get. It's the little pink means some higher rate or things like that, and then the red is usually either downtime, or in this particular case it's validation failure, because you may have heard about monorepos or monorails. You have never heard about monoperls, and that is what I'm showing you today. So our monoperl has to handle state, and this state gets pushed around our caches, and it has many clients within, and they're all internal. And as you can see from the graph is a little bit fucked. And we have other systems that depend on the service, and then they depend on the service to be three things: up, healthy, and available. So this is one of the many systems that the team that I work at oversees. But this one was the one that actually was allegedly having some capacity problems. So I was sure, let's put everything into practice within this context. So everything I'm going to talk about is one of the many systems that we have at Fastly, and it's the one I had some capacity to some capacity to work on. So all right. So we start there. A little bit more about how Fastly is structured. We split our engineering department into two sections that deal with kind of the engineering needs and also the responsibilities. So we have the edge and the core. And edge is anything that deals with cache nodes, anything that deals with like infrastructure, networking, and traffic. And in the core, we have things like API, UI, and the control plane, which is the team that I'm on. And then we deal with all of the systems that kind of support the edge as well. So that's the world. And if you want to see what the edge deals with, or what a POP looks like, I've requested some pictures. So this is what we have here. And the reason that I'm showing you the edge is because we do capacity planning at the edge with actual hardware. So I'm like, okay, cool, I don't have to figure everything by myself. I can go to this side of my organization and ask and see what we're doing there and see what I can extrapolate from the way that we deal with our hardware. So I talked to this person who's lovely. Her name is Catherine, and then she's in charge of actually like evaluating and just like weekly assessing how our POP's performance and the network capacities is going. And then she makes projections and she helps us plan everything for our footprint around the edge, and like for example new locations and things like that. You'll go to talk to Catherine because and that's what I did. And she sat with me over a few weeks and she kind of like explained to me a lot of the things that happen in the edge, and I found that very like illuminating. So all of our capacity reports are published in a way that is accessible by the entire company. So at any given point, I can go and see how our caches were doing, or how like our points of presence around the world are doing capacity-wise. And also like, it's not just about hardware. She also plans for the capacity that we have at the transit level. And that was interesting because I had never been in a situation where we actually like, I had exposure to how that part of the internet happened, or like how the internet actually worked. So I'm like, cool, tell me more. So it's about metrics that may or may not be familiar to you, but these are the things, a few of the things that we collect. And as you can see in this image that I stole one of my coworkers, there's things about transport layers that we put together, and we're going to stitch providers, and then we like plan for this capacity with the same type of estimations and predictions, or the same system that we do for hardware. Another thing that Catherine does is like she starts like plotting things out, and if something like hits a spike of 30%, she flags it, and then we monitor it, and then we investigate on it, and then if it's over 70%, it's some people like there's some activity, and then it's considered a red status, and that's as much as I'm going to cover about the edge. But the insights that I got when I was talking to her were like, okay, like this should come to no surprise to anybody, but we're like a CDN, and then yes, our capacity or our ability to correctly plan for our capacity totally limits, or is totally critical to our bottom line. The better we are, the more effective our usage, or the more effective our organization, and the more our runway that gets us. Also, another thing that she told me is that capacity doesn't necessarily involve hardware, that software optimizations matter, and you may have a prediction, or you may have like a projection that is completely great, and it's perfect and it's validated by your history, but something may change on the software level that either could give you more capacity or completely destroy the capacity that you have. And what Catherine pointed out is that at some point, one of our teams, the teams that deals with the software that runs our caches, did an optimization that allowed us to actually get a few more months of capacity for free, and that was huge. So that was great. And also like, it can act the other way around. We do request hardware, and we do provision hardware for other systems as well. And if you have a team that actually is late delivering, or is like late getting to the point where we're ready to deploy into these systems, you may have over-purchased capacity that is now sitting idle. And for us, it costs us money, because you have to rack it, you have to give it network bandwidth, we have to give all sorts of resources to this thing that is not necessarily being utilized. So purchasing hardware too soon kind of fucks you, because you have things that are just like either maybe like a few months after the road to be better, so you can get more resources for the money that you did before, and purchasing it too late is like you missed the boat and then you needed it before, so you may not necessarily be able to respond very well to the need. So that's great. That was great. Catherine was like the best conversations that I had. She was really great. And I'm like, okay, what else is there to help me? Like, so what type of like literature can I go, and what exactly can I have to help me get started? So since it's a little late now in the talk, I can tell you then, oh shit, 10 minutes. Okay, so we're measuring, oh fine, I was doing so well, they're speaking so slow. All right, I'm okay? All right, so measuring, so we have capacity planning defined. So basically it deals with like how we manage finite resources. So we make sure we plan it, and we manage a system growth, and we determine what the system needs and when it needs it. And it has to be an observation of actual traffic. Like synthetic traffic is not going to necessarily help you. And then you use your current performance as a baseline. So it's an observation on like what is happening right now. And you may have to optimize a few things, like I pointed out in the example before, but capacity planning should happen regardless, and then you should know where your things are going. So this is a section of, that is like, I'm making a call to John Allspaw, and this is probably the most I've ever put a name on my slides other than Kevin Bacon, but this is the way that John Allspaw defines this process. So you start with, we have to be this fast and this reliable. We start with the goal, and then you express that with like X per second and Y% of uptime, and then you go and you measure like your systems, and you figure out if you're reliable or not. And then you go and ask yourself this very like important question. It's like, are we the way we want to be? If you're the way you want to be, then you're cool. You figure out how to stay fast, reliable. And if you're not, then you have to start doing something for it. Either you change, you add or remove hardware, software, architecture. And this is like, it's a good process, and it's like, it was great in my mind. But I started kind of like there. So I started from like, I know we're not, and then I had to go and try to like map out the other parts of the process. And just like build from there. So another thing that John tells us is that it's very important to find your system ceilings, and then this is a critical level of a resource that cannot be crossed without failure. So it's important to know ours, and then a way that I didn't necessarily know how to find mine very well, and a way that he proposes that you do is called with control load testing. This is whenever you put your load balancer and you start taking things away from your infrastructure, and you send traffic and you start stressing the things that are there, and that's how you find like your limit, or what is your ceiling. Also, you use the ceiling data with all of your historical information to make predictions, and that is like the goal. Another thing that he points out is that system architecture can affect your ability to add capacity, and you have to identify and track application metrics, and these metrics are best if they are either expressed on business value or also like user behavior. And if you don't have ways to measure your current capacity, then you really can't do planning, so you have to go back to the very beginning. Little slow is interesting. I'm going to skip that. Basically, it's just a way that you think about like throughput and capacity, and it would be nice if you check it. But in a little bit of a summary, it's possible to have plenty of capacity. This is what I learned from the literature. That it's like completely possible to have plenty of capacity and a slow site nonetheless. Because even though like you buy some things, maybe you bought it wrong. Maybe your site is like non-responsive on the things that it's like throwing hardware to the problem. It doesn't necessarily solve everything. So that's what I learned. And also projections are curve fitting as something else that you do as part of capacity planning. You can still get it wrong if your distribution is not the one that you guess, or if your data is insufficient. So I have resources for that. And you should maybe, like, if you have an API that is public, keep track of the calls on the rate. And also, like, the thing that was like very illustrative for me, or the thing that was like kind of both good and bad, is like, well, there's always going to be situations. There's always going to be hiccups. There's always going to be like somebody doing something silly, and you take the good and the bad, and then your capacity planning should be the goal, just to be able to withhold them or not withhold them, just like plan for it and then just be able to survive it. Industry now. So I went and was like, okay, so I asked my friends and then people that I know who I think that are much better than I am, and then some of the people that are just like, this is what I got. So obviously like crowdsourced this, and I asked on Twitter. And I have a lot of like insightful or like very practical advice too. It's just like make sure that you gather relevant data as part of your day-to-day. Just make sure that it's simple. Simplicity of tools really matter. And also that just like understand the seasonality. Just also how you have to focus on the peaks and not necessarily the average, because sometimes the average hide information that you would find in the peaks. And the less predictable your demand, the more flexibility you have to build in. But then I got this advice from Rob. And Rob is a friend, so I really like him. And it was like helpful, but at the same time, I didn't necessarily want to go and put a tool on it. I wanted to be able to like take this as an opportunity to force myself to get more insight into what my system and what the architecture of this particular thing was doing. So I guess I've never used Zirconius, but if it's like as magnificent as this tweet says, then, and if you have, I would like to talk to you and see how it looks like. But I also got advice like, okay, you just keep buying until like somebody tells you not to. And then that was great, I'm sure. And then there was another one that's like, it's about following a line. And I'm like, yeah, but you have to actually make the line and be able to follow it, right? I mean, you have to have a line. So that was not necessarily super helpful. And this is my rant about what I got from industry insights. Like, it was a little bit hard to extrapolate the general advice I got with what my application needed to do. And also, like, the simplicity and ability to reason are the only things that I could trust because they're the only things that I felt that I had control over. So just like buy more hardware, it's like, it's great. It's like, what do I do now? And also, I think there's a confusing community stance on what is the ROI of capacity planning. It's like, we really don't want to do it. We're going to punt it to the next person. But I think there's some value in forcing ourselves to like map out your system dependencies and their behavior. So I'm just going to tell you something boring and be like, it's actually maybe not a bad, maybe it's not a bad thing to actually do it. So I got all of that. I had the edge, what I read more than what I told you, what people told me, and then I'm like, okay, let's put it in practice and try to solve my problem. So the step one, and some of these steps are kind of like what I call conference-driven development. It's like whenever you know you're going to talk about something, you're like, shit, I have to say something real. So we went live with this, and it was interesting. So I'm going to talk about a little bit what we found. So basically, the step one is discovery. We try to like formalize a little bit and just like do a little bit more investigation on how things were. And that was really valuable for me because it gave me more context. Then we gauge a plan and we try to figure out if the constraints were okay. And then just like we organize a team and kick it off. In our discovery, this is kind of like the flow of requests from our systems. And then I always like, so I work in the yellow. Why is this? Okay. Oh, I know it, because I'm hitting it with my hair. All right, so I work in the yellow thing, and then the system that I'm talking about is a coordinator. So it keeps states and it gets pushed to the caches, and that's where the little hand's in. And then we have two on one of our canaries. Again, this is not all of the systems we have. This is one particular one that happened to be like owned by the team that I'm in. So the edge comes from all over the world and then goes through a load balancer and then requests states from this thing. And the edge is over there before the line, and then there's a little gray line, and that is like the responsibility of my team. So that's how our requests look like. And then we needed to make sure that we weren't bringing the API and the app down, because you see that if I have a constraint at the bottom, it was affecting the level up of my system. All right, so then what I did is that we verified and confirmed that our limits were real. We came up with a plan, we went ahead, and then just like we expanded capacity, and we doubled the resource that was the most constrained, and we also like scaled it horizontally as well, and so we gave it an extra node, and all of them with like the same hardware profile. And then now we're stuck in this process of reevaluating everything. So okay, so you go, you add capacity, everything's great, you see some effect, and then you have to start again and see if the thing that you have is correct. And then right now we're starting this like performance-y bit, where we go and we reassess the configuration of the new things, because they're running the configs of the old system, and we know that they're suboptimal because they were different machines. So now we can even get more throughput of the ones that we have now. So what I'm going to show you is the throughput that we have as it is right now, as it is as of like 2 hours. So this was my system before. It was kind of like not great. And we were causing some problems with the API. And every time we deployed it, we had to drain one of the nodes. And then the other node was not able to keep up with the request, and it was just causing some availability problems on the API side. So you can see that now spikes are really like getting around 200 milliseconds, and then that was kind of like not great. So this was the system after. So after we put this, we roll it down and the system stabilized. So you should not expect something that goes like immediately, but it's like it's stabilized enough, and then now it's just like this is our throughput. So it's just almost like double at sometimes when it was really ugly. And this is the system before. There's some other graphs in New Relic where you have like this thing called the applets. It's like how responsive is your application, and the throughput. So the throughput is almost like what, like double, and then we got a much better like applets. And then the thing that I want to point out is like this is really nice for us because we had at some point an error rate of maybe 17%, and now we have a 1% error rate. So in this particular story, yes, adding more capacity is what you should do. So buy more if you need it and if you follow the process. And these are the challenges that we had. So we wanted to make sure that whenever we add capacity, or whenever you have a system that you have to do any sort of operational task on, should be no service to instruction. Localhost is the goddamn devil, because if you don't necessarily know how you're building your system and you address things with localhost, somebody should come and punch you. You may want to punch yourself, because we were there and I'm like, why is this addressing, like, what is this erroring out? And it was like something else, I got talking to localhost. So fuck localhost, it's not really good. And also something that was interesting was there was at least a cognitive gap for me from the metric. and also knowing the inside. So the gap from metric to the inside, or the graph to the inside, was a little bit huge in my mind, and maybe this is a product of not actually having gone through this process before, where I understood all of the system dependencies that I know of and the ones that I didn't. Slowness is the distributed systems nemesis. That is gonna be like interesting to track. Maybe better monitoring would have helped us for us. But then the next challenge I would run is that what I call the opera problem. So we had done it for us, and then we have other systems that were like capacity constraints. So we're like, well, we have a plan, we're gonna roll it out, and everything that we did on our handbook, we can apply it to another system, which is great in principle. But if they're not your systems, then you have to become operationally competent, or at least be able to troubleshoot when things are wrong, and that becomes really, really hard to do whenever you have pressure. Again, from Camille, like playbooks are great, and we have this thing called debug.md on the systems that we have that we're starting to fill out with like everything you should know about a system to be able to just debug it or service it. And how do you know you have a good operational handbook? If I have to escalate to you, your operational handbook is not good. So I will escalate to you, and I will be a little angry whenever I do this. So I'm like, So now this is going to be my next rant at the company. But again, I think like when it comes to this productivity and clarity, I'll give us tools. We shouldn't have waited if this happened. We should have done this a little bit above. And this is the way that now I think about this situation, where like I see monitoring as a building block for the two things, and then capacity planning is constantly a loop. Again, everything that is API driven. We found some areas for optimizations, and we found some challenges. But this is like a summary of everything. So you should monitor on everything, expensive API actions, like you should grade limit them. And also mind your system dependencies. We have a system that we were affecting because of the availability of ours, and it wasn't one of the systems that we controlled. But then the question now is going to be like, how can we better make our system defensive against each other? It's like, is there a way that we can have an architecture where like they're not necessarily messing with each other? If your organization and capacity requirements are a little bit murky, that will become complicated, and it could be a good thing, but at the same time it's a bad thing, because you may not be able to get the capacity you need until like it's very serious and until people understand. Also, this is heavily contested within my team. Your error descriptions, don't be cheeky, don't be smart, because sometimes they hide real problems. So I work with this person called Dormando. His name is Alan, and we have an error, or we have something that is called Dormando sucks. And if you've been in the company, maybe you get alert fatigue because you see it as normal part of system behavior. But I'm fairly new, and I'm like, well, Dormando doesn't suck, he's a nice person. But I completely missed that this was a real problem, and it turned out to be something that was correct. I still think it's complicated to find the ceiling of this particular system because it affects something else, and my throughput is tied to somebody else's. And since we live in a time of microservices, and everybody loves about that, and then you want ownership of that, it still means that if you don't have it's your responsibility to be ops competent. So unfortunately, you have to level up. And then I think this particular tasks that I did actually, like, they were helpful. So, but they were not easy. And I think it's just my first iteration, and I think it's probably going to take a little bit more to actually really get it. You always have to reevaluate it, and then there's some things that maybe I thought it was interesting. So if you were asleep right now, this is my TLDR for capacity planning, and specifically about distributed systems. It's a process, not a one-time event. It pushes you to better understand your system, the capacity and its boundaries, and that is a good thing. It may be hard, but it's a good thing. Productivity is best. Learning your environment really pays off. And then when distributed systems, the request lifecycle could get tricky. System boundaries and SLAs must be discussed. It would be nice if you can have a system that has SLAs against other systems. And you may be bound by people that you don't necessarily know. So there's a link to a repo where all of the resources are aggregated, and there's all of the things. And then I want to especially thank the people that helped me for this talk. So they're put in the slide, and we don't have any time for questions, but that's another picture of my Gordo, and the same thing to the thing. All right, are we good? All right.